For our project, we focused on the physics behind the human body. Emma and I will be doing 3 demonstrations where we will focus on the forces found in arm muscles, electric potentials found in bones, and how ears perceive sound. Here we have a diagram of me and Emma's arm, and as you can see, the axis of rotation is the shoulder. And we measured the length of our arm to our bicep, and as you can see, I have 3 centimeters longer than Emma's bicep does. And then we also measured the whole length of our arm, which mine was 2.5 centimeters longer. When you're doing this formula, you also have to calculate the weight. So Emma's hand and my hand have the same weight, and it's both 1 pound, which is equivalent to 4.45 newtons. We also had to find the weight of our total arm, and mine's 9 pounds and Emma's is 7.
So using all of that data, we plugged it into this formula, which we got online, and that calculates the advantage that the person has in an arm wrestle. So H would be the total weight of the arm, like Gab said, and we both have the same, we were both holding the same amount in our hands because we both have the same amount of weight in our hands. So in total, Gab's would be 174 newtons and mine's 143. So she has a clear advantage over me. Also, the length of my bicep is shorter than hers, and the bicep is what is the main form of resistance when you're arm wrestling someone. So since mine's shorter, I have less of a resistance to her force pushing on me when we arm wrestled. The second naturally occurring physics in the body is the piezoelectric effect, and the piezoelectric effect is something that happens naturally, but it can also happen, you can also force it, and it's when an electric potential is created in bones. So naturally, that can happen in dry bones because of molecular asymmetry in collagen, but it can also happen in wet bones because of something called streaming potentials, but that's a whole different topic. But you can also, the piezoelectric effect can also be seen, you can also force it in a bone. So let's say you have a dry bone right here, and you plug it up to a power source, so this could be a battery or, battery, and you flow electricity through it, it will conduct electricity, and you'll see that you'll have an anode and a cathode, so there will be a difference in voltage and a difference in electric potential. Therefore, there's an electric potential in the bone, and it can also happen naturally in your body. As you're just standing, there can be an electric potential in your bones, and you don't even know it.
The piezoelectric effect happens naturally through mechanical stress, and this is when gravity is working its way on the bones, and this can be through different forms of exercise, such as walking, jogging, running, even just lifting weights. And so this helps because it stimulates bone growth and repair in the bones, which is needed for the body.
Humans can hear from frequencies of about 20 hertz to about 23 kilohertz, which is 23,000 hertz, while dogs can hear from about 40 hertz to as far as 45 kilohertz, which is 45,000 hertz.
The human ear is made up of 3 parts: the external ear, the middle ear, and the inner ear. The outer ear is called the pinna, which is located right here, and it's made of rigid cartilage that is covered by skin. Sound funnels through the pinna and external auditory canal, ending at the tympanic membrane, which is known as the eardrum. Sound causes the attached bones on the eardrum to vibrate, and the vibrations are conducted to the nearby cochlea. The spiral-shaped cochlea comprises the inner ear, and it specifically transforms into nerve impulses that travel to the brain so we can hear. Hi, this is a dog, and a dog's ear is similar to ours, but also slightly different. A dog's outer ear also consists of a pinna, which can be upright or floppy, and in this case, my dog's ears are upright. Stop. And this can just vary depending on the breed of the dog. So when a dog's ear is upright, it becomes cupped, which allows them to hear better than us. And a lot of times there'll be experiments when you'll tell a human to cup their ears because they can hear more sound. But that is what a dog's ear is like normally. So the ear flap funnels sound into the ear canal, which is much longer than ours. So a dog has a 2-inch long, narrow ear canal that makes a 90-degree bend as it travels to the deeper parts of the ear. This allows dogs to hear sounds that we don't even hear at all. Once sounds enter this canal, it causes the eardrum or the tympanic membrane to vibrate, and the cochlea, which comprises the inner ear, connects to the brain so that a sound can be perceived.
The human and dog ear anatomies are both very similar to each other, but dogs' ears are cupped, and they have a cupped pinna, and also they have longer ear canals, which allows them to have a greater mobility than humans' ears. Therefore, they're able to hear a wider range of sounds. Oh,